Hello students, so now we're going to start with our next thing, that is addition of vectors in component form. Okay, so if two vectors are given in terms of I cap, j cap and k cap, then how we add those two vectors, that we're going to see in this part. Okay, now let's start with, okay, so what we have given, as I have told you, we have one vector given, a vector, that is ax I cap plus ay j cap plus az k cap. Okay, and you have b vector that is given bx I cap plus by j cap plus bz k cap. That's how. Okay, and also you have this thing that to find out the c vector, that is a vector plus b vector. Okay, so what can I see here, that then what I will write down, I will say that x component of c vector will be coming from the I cap, this ax and bx, right? So ax plus bx. Okay, and similarly y component of c vector I can write is coming from ay and by, so ay plus by, right? And z component of c vector is going to come from az and bz, right? This is my components. So I can say c vector equal to cx I cap plus cy j cap plus cz k cap. Okay, simple. What can I see here? Here my cx is equals to ax plus bx, right? Just adding the x components together. Okay, all the x adding and y add and z added. Okay, simple. Cx, similarly what can I write for cy is equals to ay plus by. Okay, cz I can write az plus bz. Okay, that's how. Okay, so here I can say what is the magnitude of c. How you will find out magnitude? Under root of cx square plus cy square plus cz square, right? What can I say? Cx square plus cy square plus cz square, right? This is your magnitude of c vector, I can say. Okay, I hope this is clear, and this is very, very important, you can remember. Okay, so how you will do this? You will just add I component with I component, j component with j component, and k component with k component. Okay, simplest thing. Okay, next we have a note. What we is saying, rectangular component of vector are component having angle 90 degree between them. In general, rectangular component are means I cap, j cap and k cap. So here we seen addition of vector in component form. Okay, and what we are saying is that you have to find out the magnitude of c. Then how you will write down? Under root of cx square plus cy plus cz square, where cx, cy, zz are addition of x component, addition of y component, addition of z component. Simple. And this is your in vector form. Okay, now he is defining the next term, that is rectangular component. So what are rectangular components? Any three component, take any three axes which are perpendicular to each other. Okay, all three should be perpendicular to each other. In general, when we solve, we take three, which we take is axes which are perpendicular. We know x axis, y axis and z axis are all perpendicular to each other. So along that we can take I cap, j cap and k cap. Okay, that's how you can solve. Okay, next thing is saying is equilibrium. What is the meaning of equilibrium? Okay, what is the meaning of equilibrium? Where the net force on the body is 0. Okay, so sum of all the forces are 0. Okay, F net equal to 0. We know force is a vector quantity. This is just defined for the one question. Okay, that's all. Okay, so if someone asks you is the system is in equilibrium, means you do the net force, all the vector sum of the all the forces equals to 0. That's how you do. Okay, now let's solve next one question. So what this question is saying is, write a vector and b vector, a vector, b vector and c vector into rectangular component form and find a vector plus b vector plus c vector, where a, b, these values are given, these angles are given. Okay, fine. Now let's solve. Okay, so first let me write down, this is your a, this is your b, and this is your c. Okay, so if we have already written how to find out in component form, right? So that I am not gonna tell you how to solve that. So that I can write directly, a vector equal to 5 j cap 5 root 3 I cap plus 5 j cap. Okay, and b vector, simply you have to take cos theta sin theta, that angle. Okay, and b vector is gonna be equal to 3 root 3 j cap minus 3 I cap. Okay, you can change I cap first, j cap last, whatever, it is same thing. Okay, c vector I can write as minus 4 root 3 j cap minus 4 I cap. Okay, this thing we have already done. Now he is telling me find out a plus b plus c. Okay, there we have seen two vectors, here three vector, a vector plus b vector plus c vector. Okay, so I am gonna add I with I, all I together and all j together and all k together. Okay, that's how it's gonna be added. Okay, so here I component is 5 root 3, here minus 3, here minus 4. So I can say 5 root 3 minus 3 minus 4 I cap plus j cap together, 5 plus 3 root 3 minus 4 root 3 j cap. Okay, that's gonna be a vector plus b vector plus c vector is equals to 5 root 3 minus 7 I cap plus 5 minus root 3 j cap. This is your final vector. Okay, I hope this is clear. Component form we have already resolved, so you can resolve this thing. Okay, now, okay, fine. Next part we have is position vector. How to define a position vector? This is very, very important. We will define a position vector of anything. Okay, how to do that? So we have position vector. Position vector gives us location of a point with respect to another point. In general, vector represents position vector of head with respect to the tail of any vector. So what we are saying is, position vector is basically telling me the position of head with respect to tail. Okay, if I go to tail, okay, and I ask him that where is the head, so he will point out towards this direction, towards a particular direction, and he will tell me that it's in this much magnitude. Like let's say here is this tail. Okay, and I ask him where is the head. Okay, then he will say in this direction you go with a magnitude of some a. Okay, so he is giving me a magnitude and he is giving me a direction. Okay, means he is giving me a vector. So basically the position vector is the vector which is telling me the direction from tail to head. Okay, direction of head with respect to tail. Okay, basically direction of head or position of head with respect to tail. Okay, position of head with respect to tail, I can say that, right? I hope this is clear, right? Now let's write down. Okay, so position vector of point A with respect to origin. If I want to define, if I ask origin where is A point, okay, that is telling me A is at x0 comma y0. That is in coordinate form. If I want to ask him in vector form, then I have to find out this vector, right? So I can write r vector is x0 I cap plus y0 j cap, right? This I hope this is clear, right? This is x0, this is y0, right? So this is gonna come x0 I cap plus y0 j cap, right? This is position vector. If you want to find out a coordinate x0 y0, its position vector with respect to origin, so that is x0 comma x0 I cap plus y0 j cap. Okay, now let's write down for position vector of point A with respect to B. So point A is something and point B is something. Okay, so from here with respect to B, from B is tail and this is head A, right? So I want to find out, first write down RA, position vector of A with respect to origin. That is what it will be, x1 I cap plus y1 j cap, right? Position vector of B, what it will be, I can say x2 I cap plus y2 j cap, right? Okay, and if you see in this triangle, what can I say here? RB vector plus RAB vector is equals to RA vector. Okay, so here RAB vector is equals to RA vector minus RB vector, right? So RAB is equals to RA minus RB, right? So that is my x1 minus x2 I cap plus y1 minus y2 j cap. Okay, this is my position vector of A with respect to B. Position vector of A with respect to B. Easy to remember, I guess. Okay, how to remember? Final minus initial. Final minus initial x coordinate, final minus initial y coordinate. Now you can shift this B as origin also 0, 0. If you take it 0, 0, it's coming same, right? So that's how you can, for 0, 0 it's also valid. So this is your position vector of A with respect to B. That is x coordinate minus x coordinate minus x coordinate, y coordinate minus y coordinate, like that. Okay, easy to remember. Now let's do a question on this. What this question is saying, find position vector of 3, 4 with respect to 0, 2. So position vector of A with respect to B. Okay, so this is your point A, this is your point B. Okay, you have to see this also. AB if I am writing position of vector of A with respect to B, AB. Okay, so that is 3 minus 0 I cap plus 4 minus 2 j cap. That is how much? 3 I cap plus 2 j cap. Okay, this is your position vector of A with respect to B. Find a vector from 1, 2 towards 2, 4. So from 1, 2, starting from 1, 2 towards 2, 4, like this. Okay, so what it will be? Our vector 2 minus 1 I cap plus 4 minus 2 j cap. That is I cap plus 2 j cap. Okay, next question is find position vector of A with respect to B. So A and B are given. So R A B, A with respect to B. So this should do the subtraction. 1 minus 0 I cap plus 2 minus 1 j cap plus 3 minus 2 k cap. Okay, so R vector AB, that is I cap plus j cap plus k cap. This is my RAB. Okay, I hope this is clear. Next thing, we have unit vector. Okay, we are defining the unit vector again. Okay, just in the like we are doing the questions now here. Okay, so what we said about the unit vector, let's see again. A vector is equals to A magnitude into its direction, A cap. So what A cap came? A cap is basically vector divided by its magnitude, right? That is vector and divided by magnitude of vector. Magnitude of vector. Okay, so if you want to find out a unit vector in a particular direction, let's say in A vector direction, then you will divide with its magnitude and you got the, so this is your, you got the A cap. So this is your unit vector, or we called it direction vector also. That is only giving me the direction, it is not giving me any magnitude. Without magnitude it is unit vector. Okay, example. Okay, example we have, let's say A vector is given 3 I cap plus 4 j cap, 4 j cap, and I want to find out the A cap. So A cap basically A vector divided by magnitude of A. Magnitude of A is how much? Under root of 3 square plus 4 square, that is 5. So 3 by 5 I cap plus 4 by 5 j cap. This is my unit vector. Okay, if you check the magnitude of this, it will gonna come 1. Okay, next question, find a unit vector directed from 1, 2 towards minus 2, 1. So first find out the position vector from 1, 2 towards minus 2, 1. Okay, so R vector, if you get this R vector, first find out the vector, then you will convert it to unit vector. That is not a big deal. Minus 2, minus 1 I cap plus 1, minus 2 j cap. Okay, R vector is equals to minus 3 I cap minus j cap. Okay, this is your vector. Now I want to find out R cap. So r cap is basically r vector divided by magnitude of r vector. Okay, that is r vector minus 3 I cap minus j cap divided by magnitude, that is under root 10, right? I hope this is clear. Next question, find a unit vector along a vector. Okay, a vector, unit vector we have to find out. So first just find out the a vector. What is the a vector? 10 cos 53, 10 cos 53 I cap. I hope this question is complete. Yeah, plus 10 sin 53 j cap, right? So a vector is equals to how much? 8 j cap 8 j cap plus 6 I cap. Okay, so if you find out a cap basically a vector divided by magnitude of a, right? So that is my 6 I cap plus 8 j cap divided by magnitude, that is 10. Okay, that's how. Next question, find a vector whose magnitude is 10 and direction is same as 3 I cap plus 4 j cap. Okay, so now this question is good question. Okay, if you have not seen this before, then this is a good question. So I want to make the magnitude to be 10 and I want direction to be same. So magnitude is given and direction we have to take out from here. So let's take the direction. We want to make unit vector. So unit vector is a vector divided by magnitude of a. That is my 3 I cap plus 4 j cap divided by 5, right? This is my unit vector. Now I want to find out such b vector that magnitude is 10 and direction is a cap, same as a cap, right? 10 into a cap, just do that, 3 I cap plus 4 j cap divided by 5, simple, right? That is 2 times, so 6 I cap plus 8 j cap. So now these are parallel vectors, right? Direction is same and magnitude is double. So this is 5, this is 10. Okay, next question we have, so we have a vector making angle 37 degree, b vector that is 3, and c vector that's given theta. Find magnitude of c and angle theta so that resultant of these vectors is 0. Resultant of these vectors is 0, right? So let's write down one by one. We have a vector, component form you can divide, right? So component form, if you divide, you will get 8 I cap plus 6 j cap. Okay, b vector is already in direction, so I cap direction, so 3 I cap. C vector, if I write down, c vector is my magnitude is c, right? So I can write minus c cos theta I cap and minus c sin theta j cap. Okay, and now he is saying resultant of these three is 0, means a plus b plus c equal to 0, he is saying. So let's add. So I cap will be added together, so 8 plus 3 11 minus c cos theta I cap plus 6 minus c sin theta equal to j cap equal to 0, right? So it is equal to 0 means your I component is also 0 and j component is also 0. So I can say 11 minus c cos theta is also 0. From here I can conclude this, and 6 minus c sin theta equal to also 0. Then only it will come to 0 vector, right? Both the component is 0. So I can say from here c cos theta is equals to 11 and c sin theta equal to 6, right? So from here I can say tan theta equal to what he asked, theta only and magnitude also. So tan theta equal to 6 by 11. So your theta came tan inverse 6 by 11. Okay, simple, just writing inverse, nothing else. And c, if you find out, if you eliminate this thing, okay, you will get the c, you square and take the under root, so both sides you square and add both of them. Okay, so c square, c is equals to under root of 11 square plus 6 square. You can find out 2 equation 2 variable. I hope you will able to do. Okay, so c you got, c goes to under root 157. Okay, this is your answer, c and theta. Okay, I hope this is clear. Now let's go for next thing, which is the resultant of A vector and B vector is directed along y-axis. Then find magnitude of B vector. Okay, resultant of A vector and B vector is directed along y-axis. Okay. Along y-axis it is directed, along x-axis it is not. Then magnitude of B vector. First write down A vector in x, I component and j component. If we saying x and y, then write down x and y. That's all. So A vector, if you write down, you have 10 cos 30 I cap plus 10 sin 30 j cap, right? So A vector is going to come how much? 5 root 3 I cap plus 5 j cap. Okay, and similarly B vector, if you write down, angle is given, right? So this is going to come b by root 2 I cap and plus b by root 2 j cap. Okay, now he's saying it is along y-axis, resultant of A and B. So A vector plus B vector is towards y-axis, means sum in the x-axis is 0. Along the x-axis is 0, means 5 root 3 minus b by root 2 is gonna come 0. Okay, so from here I can say b is equals to 5 root 6. Okay, so this came my magnitude. Okay, because it is directing towards y-axis, so y-axis component is some value and along x-axis it is 0, right? So along x-axis add and put it equal to 0, I component 0. That's how b came root 5 by root 6, 5 into root 6. Okay, next question we have, if magnitude of addition of two vectors is 3 times of magnitude of their difference, then find angle between two vectors. What is saying, magnitude of addition of two vectors means A vector plus B vector ka magnitude is equals to 3 times of magnitude of A vector minus B vector. Then find angle between them. So let's expand this, A square plus B square, and both have same magnitude, that also written. A square plus B square plus 2AB cos theta we know, and we have to find out theta only. And here 3 times of A square plus B square minus 2AB cos theta. Okay, and A and B are equal. So if you resolve from here and you will put A equal to B, then you will get cos theta is equals to 4 by 5. Okay, so from here theta equal to 37 degree I can see. Okay, you can solve it. A equal to B, if you put all things, will cancel out this 2 times, and okay, like that. Next question we have is, 3 vectors having magnitude 2, 4 and 6 are directed along 3 sides of an equilateral triangle. Then find magnitude of the resultant of these vectors. Okay, so what is given here? Three vectors. So this is 2 and this is 4 and then there is a 6, like this. It is 3 vectors directed along the side of equilateral, means this is 60 degree, 60 degree, 60 degree, 60 degree. Okay, like this. Now if you resolve this in x-axis and y-axis, that will be better, right? So 2 you put here, 2, let me put it little bit shorter, 2 is here. Okay, then your 4 is here at 120 degree. Okay, and then your 6 is here, and an angle of 120, 120, 120. So this is 90, this is my 30 remaining, right? And this is my 120, 150, and this is my 60, right? 60 and that is 60, 120, right? This is how. And now you can resolve and you can find out the resultant vector. So let's find out. Okay, I am pointing at this as A, this as B, and this is C vector. Okay, so A vector, if I resolve, it is already resolved, only 2 I cap. B vector, if you resolve, you will get B vector is equals to minus 2 I cap plus 2 root 3 j cap. And C vector is equals to minus 3 I cap minus 3 root 3 j cap. Okay, so he is asking A plus B plus C. Okay, what we can write about A plus B plus C? It is sum of these. So this is gonna minus 5 minus plus 2, so minus 3 I cap, and this is gonna add, that is minus root 3 j cap. Okay, magnitude. Okay, magnitude is asking. Let's calculate the magnitude also. That is under root of 3 square plus 3, that is 9 plus 12 under root 12. Root 12 is the answer, the final answer. Next we have a note. What this note is saying, that if you have to check that if two vectors are parallel or not. So if their ratio is coming equal, okay, ax by bx equals to ay by by and az by bz is equal, then it is parallel. Okay, and it should come positive. Okay, then it is known as parallel. If this ratio is coming equal and negative, then it is anti-parallel. Okay, so if you want to find out it's parallel or anti-parallel, and if it is not coming equal, that means they are not parallel or anti-parallel. If it is coming equal and then it is positive, the ratio is coming positive, whatever ratio, lambda, okay, that is coming positive, then it is parallel, and if it is coming negative, then it is anti-parallel. I hope this is clear. Okay, thank you.